Okay, so we're going to skip down all the ways to exercise on this one. And it's just going to ask us to graph and determine the domain and range and see if it's a function, and if it's a function, if it's one-to-one. Then we're going to set if it's discrete or continuous. So, with 1, you notice this is a constant function, right? Because you just have a constant at 3. So, and this is a function but is not one-to-one, because for every x you're going to have exactly the same y, so it's not one-to-one. And your domain is going to be all real number, and your range is going to be y equals 3, or you can write it in a set notation with the squiggly parentheses. And this is a continuous function, right? Because it's all connected. Now, let's go to 2. If you notice, you have a negative number outside the parenthesis. So that tells us we're going to go down 1. And since you don't have any stretch factor in front of the x squared, you know you can still use the 1, 1, 2, 4. So 1 over 1 up, 2 over 4 up. And then you can reflect on the opposite side. And this is a function but is not one-to-one, because at -1 and negative and positive 1 you have the same y's at 0, so it's not one-to-one. Your domain, again, is going to be all real number. Your range is going to be y is greater than -1, or you can do it in interval notation, -1 comma infinity, because it's going up forever, right? And this is a continuous function. Now, 3 is a linear function, and you notice there's a 2 outside the parentheses, so we're going to go up 2, and you notice there's a 3 in front of that x, so it tells you to stretch it by 3. So I can't really go up because it's going to give my point outside our grid. So what else you can do is go the opposite way. So left 1, down 3. Left 1, down 3. And you can get our graph. And this is a function and it is one-to-one. Now our domain is going to be all real number, and our range is going to be all real number as well. And this is a continuous function. For 4 through 9 what you're really doing is replacing x with 12 and then solve. So what I like to do, I like to replace all my x's with parentheses first. And then inside that parenthesis, I'm going to plug in whatever number I'm supposed to replace it with. So now, solve negative 2 times 12, that's negative 24, plus 4, that's going to give us negative 20. So f of 12 is equal to negative 20. Same thing for 5. I'm going to replace the x with parentheses, write my whole equation down, and whatever I'm supposed to replace x with, I'm going to plug that number in. In this case, is 6. So negative 2 times 6, that's negative 12, plus 4, that's negative 8. So f of 6 is equal to negative 8. Now, when you see that you're replacing is not a number, it's a variable, all you're really doing is plugging that variable in for where x is supposed to be. At this point, you got to distribute, and I'm going to call it good. That's all you have to do for that. So here with 7, you're going to replace 5 in for these x's. Now 5 cubed, that's 125. 125 minus 5, that gives me 120. Now g of 5 is 120. Same thing for 8. I'm going to replace all my x with parentheses and plug in that number. Negative 2 cubed, that's going to give me negative 8. And here you have a minus a negative 2, which really is a plus 2. And negative 8 plus 2, negative 6. So g of negative 2 is equal to negative 6. Again, 9 and 6 are very similar. All you're going to do is plug in this 7c in for x. First, I'm going to replace all of my x's with parentheses again. Plug in my 7c. And now, when you're distributing this cube into 7c, you have to multiply each number individually. So 7 cubed, it's 147, I believe. Let's check. Oh, very wrong. $341. 343, and you're going to cube the c, and this will be your answer. G of 7c is equal to 343c cubed minus 7c. And that's it for today.